Imagine you are a caveman from 50,000 years ago and you are suddenly transported to the worst time life on Earth has ever seen. The year is roughly 251,920,000 BC, and at first you're a little confused as to why you're suddenly in the middle of the desert. Thankfully, this confusion won't last very long because within less than 10 minutes, you'll be dead. The first thing you notice after you are transported is the sky. Instead of blue, you see colors of yellow and orange, thick with volcanic dust and gas. You struggle to breathe. Oxygen in this atmosphere is poor, and everything smells like rotten eggs and burnt plastic. You're completely naked to the blazing sun with temperatures of 60 degrees Celsius. There is no humidity, and there is no wind to cool you down. After a minute or two, your skin starts to turn red. You attempt to walk, but you soon collapse into the burning hot sand as you feel dizziness consume your body. In your last moments, you're probably left hallucinating and convulsing before your organs stop working. No animal is left to scavenge your remains. Instead, the sun will ultimately cook your organs and break your bones like dust. But hey, that is the absolute worst possible scenario for your survival at this time, so we can only go up from here. The extinction event that marked the end of the Permian in the geological timeline is often referred to as the Great Dying, and for good reason. It was the worst loss of life Earth had ever seen so far, wiping out around 90% of all the species that were around at the time, 70% of all terrestrial species and up to 95% of all marine life. The actual event lasted around 200,000 years, but most of the actual dying part probably only happened within the span of 60,000 years, although some studies say even a window as short as 20,000 years could have been possible. There are a whole lot of reasons as to why Earth turned into Mad Max but worse 250 million years ago, but the biggest reason most scientists agree on was the volcanic activity in what is now the Siberian Traps, a landmass of volcanic rock. These volcanoes exploded and pumped a whole bunch of CO2 into the atmosphere over the course of thousands of years. This actually happened at a rate slower than the rate at which we are doing it nowadays, which is slightly terrifying to think about. But back then this process just kept on going until the planet was a rather terrible place to be. The lava flows covered an area the size of the United States with a layer a kilometer thick of basalt rock, which made Earth inhospitable for the next 5 million years. The intro of this video was a description of what it would probably have felt like to be dropped in the middle of the Pangean desert during this time. Long story short, you die very fast. But what would it take for you to not die? Let's find out. Could modern human society survive a modern-day Great Dying? Perhaps you may think that all 8 billion of us have a larger chance of making it out alive than the comparatively much smaller human population from, let's say, 50,000 years ago. After all, we are much larger in numbers, and we do possess the technology to maybe predict certain disasters from taking place. In this video, I want to analyze what the odds of survival could have been for humans for different points in a comparatively recent history. Because my research question specifies modern humans, we will only be looking at the species Homo Sapiens, so no Neanderthals, Denisovans, or any other extinct human species. Our first group will contain 20,000 Homo Sapiens who were around 50,000 years ago. I chose this time frame because back then we still lived a hunter-gatherer lifestyle, many years before the agricultural revolution. The second group will be all of human civilization as of 2025, so roughly 8.2 billion people. I'm going to describe to you exactly how you could survive, if at all, and the many ways in which you could die. So just imagine you are my test subject for the world's first time machine. But before we discover how screwed you truly are, let's put up some ground rules first. Our groups of humans, including you as my imaginary test subject, will be transported to 2,000 years before the worst part of the Great Dying, when volcanic activity was already rampant and Earth was already in a dire condition. The groups can get a bronze, silver and a gold medal based on how long they survive. They can only officially fail once every single human has been wiped out. There are 2 major time periods which will present the biggest challenge to the human survival. The first one being the main events that caused the Great Dying. This happened around 251.9 million years ago, and could have probably lasted somewhere around 60,000 years ago, although with a margin of error of 48,000 years ago, meaning that it could have lasted quite a bit longer or quite a bit shorter. If there is still a human population around directly after this event, even if it is small, the humans will get a bronze medal. Earth needed a long time to recover after this catastrophic event, and you could say the quote-unquote Great Dying lasted millions of years. After the worst of it had passed, Earth was still mostly in ruins. For up to 10 million years after the extinction, there was a noticeable absence of coal in the fossil records from that period. That indicated that there were no large trees and forests that could produce peat and subsequently make coal production possible. So for millions of years, the world mostly consisted of either desert or shrubs. The next challenge will be a 1.5 million year period in the early Triassic, right after the Great Dying, known as the Late Smithian Thermal Maximum. I chose this period because at the time, Earth experienced an extreme spike in global temperatures, likely caused by, you guessed it, volcanic activity by the Siberian traps. A study from 2012 reconstructed the ocean temperature during this time by analyzing the teeth of conodons. They're so beautiful. The average temperature of the ocean was 40 degrees Celsius. For reference, the average temperature people shower at is usually between 37 and 41 degrees Celsius. This is also probably why marine life was hit even harder than terrestrial life. If you were to survive this terrible time in the early Triassic, you would get a silver medal. It could have taken up to 10 million years before Earth was back to its original levels of biodiversity before the extinction. However, 5 million years after the event, the first signs of more complex plant species began to appear, or more so reappear, and new species began to evolve who could later thrive instead of just hanging on by a thread. If you managed to survive until this time, not only would that be quite impressive, it would also get you a gold medal. Now let's take our group of 20,000 hunter-gatherers from 50,000 years ago and transport them to the late Permian and scatter them all across the coasts of Pangaea. What could possibly go wrong? For the sake of my experiment, I can bring you back to life as many times as I please, and I can also wipe your memory to rid you of the probably traumatic experience you went through in the middle of the Pangaean desert. This time you're heading for the same latitude but a different longitude, right here by the Paleotethys Ocean. Unlike inland Pangaea, this place is extremely wet. It's a perfectly terrible 40 degrees Celsius and it's extremely humid. Within a minute, you're covered in sweat. Since you are so close to the coast, you decide to go for a swim, even if this place does smell like rotten eggs. You guess that must be your smelly neighbors. However, the water does not cool you down one bit. It's about the same as taking a hot bath. Because you came from the Neolithic period, you probably had no idea surface water could get so warm in the first place. The water has a strange green color since it is full of algae, most of it probably dead. Before long, your eyes start itching and your nose feels like it inhaled a Carolina Reaper. To top it all off, you now have developed a nasty cough. Strangest of all, you don't smell rotten eggs anymore. Actually, you don't smell anything at all. Feeling more dishes? That's not a word. Feeling more nauseous and dizzy instead of refreshed, you decide that going for a swim was maybe not the best idea, and you decide to go back onto land. There were a few times in your life when you were as sick as you are right now, and you've only been here for 5 minutes. The land here has a yellow-orangish hue, and most of the plant life was limited to ferns and small shrubs. Nothing too impressive.
Don't you dare disrespect my children like that. We are perfectly impressive.
It's a dry, desolate landscape in desperate need of some rainfall. Guess your luck when you look up at the sky and see dark clouds forming in the sky. It seems finding fresh water won't be nearly as difficult as you thought. The sound of thunder rumbles ominously overhead, but you've experienced this a couple of times during the Neolithic, so it couldn't be that bad. The Permian coastlines during this time were not just mostly devoid because of the drought. Pangaea had seasons like our planet does nowadays. The only difference here is that Pangaea only really had 2 seasons and they were both terrible. There was either nowhere near enough rain or far too much of it, and you have just found yourself at the beginning of the wet season. This cycle would have baked the soil and plant life during the dry seasons, only to be completely stripped away and eroded during the wet seasons. You absolutely would not have been able to drink the rainwater safely. It had the same acidity as vinegar or lemon juice, but with a number of chemicals that would have killed you, such as sulfur, chlorine, and fluorine. In this situation, death is unfortunately imminent. The death toll of the Great Dying didn't affect the entire planet equally. Whereas certain huge areas were almost completely ridden of all life, there were also a few places that were not as damaged.
Oh my fucking god, she fucking dead.
The extreme weather that battered most of this supercontinent was not as extreme in the far south. Back when Antarctica was at the South Pole like it is today, the landscape may not have been as scorchingly hot as the lands around the equator, but it was also nowhere near as cold as Antarctica nowadays. The climate appeared to be relatively stable. It was consistently humid, but without the torrential downpours of elsewhere. Many fossils of Lystrosaurus have been found in South Africa, which also would have been relatively far south 252 million years ago. This species was so successful that in some fossil beds, Lystrosaurus made up around 95% of all the species found there. They reached their peak right after the Great Dying in the early Triassic, making up around 70 to 90% of all terrestrial vertebrate individuals found from this time. In that regard, Lystrosaurus was arguably one of the most successful animals to ever exist, despite its rather lackluster appearance. Its biology made it much more adept at handling the changing world the Permian ecosystem had to endure. They had various traits that made them more hardy against the low oxygen, high CO2 world. A barrel chest, high neural spines, and maybe exceptionally large lungs. Furthermore, its diet was quite simple, likely consisting of horsetails and lycopids that weren't destroyed by the weather and the toxic atmosphere. It is believed this silly-looking animal was a burrower, which could have shielded it from the oppressing sun. Humans would not have been nearly so lucky in southern Pangaea. The coast here would be much as the same as around the equator, but the areas with higher elevation could pose a better chance at survival, even if that chance is minuscule. Air becomes much thinner the higher you go. Nowadays, oxygen makes up around 21% of our atmosphere. In the early Permian, that number was much higher at around 30%. However, oxygen levels plummeted to between 12 and 16% at the very end of this period. This would be equivalent to breathing at an altitude of 3,000 meters, even though you are at sea level. If our group of humans was forced to live in the high plains of southern Pangaea, they would quickly have to adapt to the lower oxygen levels there. Unfortunately, this air wasn't just thin, it was like breathing stale, poisonous air in a sealed, crowded room that is also on fire. Since our group probably lived much closer to the sea level, all of them would develop some sort of altitude sickness, since even at an altitude of 1,000 meters, it would be more similar to an altitude of 4,000 meters. There's a decent chance you've been on top of a mountain that was maybe even taller than 4,000 meters, myself possibly included, but you likely didn't have many, if any, health issues then. That is probably because you at least had some time to get used to the higher elevation for a few days. With proper time and training, even if it's unintentional, you would be able to live at a higher elevation for days without many problems. If I were mean enough to not give these 20,000 Neolithic hunters any time to acclimatize, a lot of problems would ultimately arise and most of the group would probably die very fast. And that is without keeping in mind the other toxins such as the massive amounts of CO2, heavy metals, and hydrogen sulfide. Still, in the south, these toxins would more so lead to irritation and problems over time instead of an immediate and quick death. Even if the humans did get the chance to acclimatize, their chances of survival in this part of the continent would still be slim. Edible plant-based food would have been close to impossible to find, at least for humans. Our diet would likely consist of Lystrosaurus and perhaps a few other cynodonts and dicynodonts. The cynodonts are effectively the ancestors of all mammals, including us. The humans could have to resort to hunting their own grandparents from a couple of million generations ago. If the cynodonts were wiped out along with the many other genera who kicked the bucket during the Great Dying, the entire mammal lineage could never have existed. The southern plains of Pangaea were simply too toxic to sustain human life for a long period of time. This place really wasn't a functioning ecosystem, but more so a barren wasteland that happened to have a couple of survivors who could eat the plants no one else could, like Lystrosaurus. Our humans can only get a medal if they survive the main extinction event. However, in this case, it would be impressive if they survived the 2,000 years before the extinction event too. Human ingenuity and our ability to survive in harsh conditions is certainly impressive, but it is not much use when basic needs like clean water and air cannot be met. Before we start talking about how modern human civilization would fare, I first want to introduce to you the place where our group of early Neolithic hunters actually could have stood a chance at survival. A study from this year described how an area in what is now Xinjiang, China, was much more habitable than any other place on Pangaea that we know of. Which is kind of ironic considering nowadays it looks like stereotypical Pangaea. Unlike the extreme seasonal differences that destroyed ecosystems elsewhere, studies show that the Turfan depression got an annual rainfall of 1,000 millimeters each year, which is a bit rainier than what I get in the Netherlands. The stable hydrological cycle likely made the acidic rain less severe, allowing for greater plant growth. The extinction of plants here was only at 21%, much lower than rates elsewhere. Some fossils have even been found from this time that were previously thought to originate in the Mesozoic, aka the time of the dinosaurs, which could suggest that plant life evolved here without interruption. What may surprise you is that the Turfan depression was relatively close to the Siberian traps. Therefore, you would expect this place to be a barren wasteland. But since it was a lower lying area surrounded by mountains, these mountains likely filtered much of the clouds that contained all the bad stuff that could have killed you. Or at least some of it. Fossils suggest this area recovered 10 times faster than the rest of Pangaea. The consistent, non-lethal weather system is what gave the plants a chance to grow, which in turn attracted many organisms, or perhaps just let the animals that already were there stay there. Animals that called the Turfan area home included of course Lystrosaurus, but also other animals such as the Chronosuchians, which is sort of an ancient crocodile, and the Turfanodons, which is basically a Lystrosaurus wannabe.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
All these trees and animals are wonderful, but the real question is, could humans have survived here? I think so, and I'll explain why. Let's start with water. The steady precipitation of the basin would have diluted the acid rain and made the water much more drinkable. It would have to have been that way, otherwise life would have died off like everywhere else. Whether humans could have drunk this water is a different question, and one we may not have a definitive answer for. However, I'll give them the benefit of the doubt and say the water won't be harmful to them in the short term. Even though plant life was diverse, we couldn't really eat any of it since there were mostly trees, ferns, lycophytes and other inedible things, at least for us. Although there are people nowadays who seem to do just fine with eating only meat, such as the Inuits, we can't really know for sure if a diet consisting of only Lystrosaurus and Chronosuchians would be enough to sustain Homo Sapiens. However, if the humans were to hunt several species and eat not just the muscles but the skin and organs as well, most of their nutritional needs could be met. Then of course the problem of overhunting could become a real issue. If I'm being pessimistic, I could even say it could spell their doom, unless the total human population were even smaller. Or they could invent domestication, but that would be very unlikely before the Great Dying, within the span of 2,000 years. The trees won't just be there as decoration for the new late Permian human community. They can provide important materials for shelter, cooking and utensils for hunting. But the greatest threat is, you guessed it, the atmosphere. The atmosphere had 10 times the amount of CO2 than what our hunter-gatherers are used to. Big, crowded rooms with poor ventilation can sometimes reach levels up to 3,000 parts per million, and the maximum legal amount of CO2 allowed in workplaces for a duration of 8 hours is set at 5,000 parts per million. For reference, the outside world has an average CO2 level of about 400 parts per million. So the humans may feel a little groggy or experience brain fog, but their life won't be in immediate danger because of CO2. They're also quite lucky there aren't any animals as scary as what they experienced in the Neolithic, since all the top predators of the Permian were all wiped out, or were already in decline near the end of it. Despite all these promises of a place that won't immediately kill you, a lot of the initial 20,000 humans would die off relatively fast. The thin air of the Permian may not have been immediately lethal, but it still came with a lot of problems. Without training, probably half of the population would die off within the first few days, most notably the sick, the very young, and the very old. Eventually, after a couple of generations, our physiology would be better equipped at handling the thinner air. There are some surprising benefits of the combination of low oxygen levels and the abundance of Lystrosaurus. With a much smaller human population, with perhaps only 1,000, the risk of overhunting Lystrosaurus decreases. Lystrosaurus were probably quite easy to catch too, since one of the reasons they were able to thrive was because of the lack of predators. They likely would have no way of defending themselves, a crucial benefit in an environment where the high CO2 levels would have made hunting, often a very physically demanding activity, very difficult. I'm willing to bet a very small group of humans could have survived the Great Dying in this basin, even if in local terms the term the Great Mild Inconvenience would be more appropriate if we're talking about the ecosystem that was already there. So in any case, the humans get a bronze medal for choosing the Turfan depression and surviving the Great Dying. Whether this small ecosystem remained largely intact throughout the early Triassic is a different question. However, luckily for me, there was at least one study done on this particular area during the Triassic. When analyzing the growth rings of plant fossils, researchers have deduced that the climate in the Turfan depression in the first 2 million years of the Triassic did not appear to be as stable and consistently humid as it once was. Dry periods grew increasingly common. However, when compared to many other places in Pangaea at the time, the Turfan depression remained a refuge for life, since trees and other flora appeared to be mostly unaffected. The bones of Lystrosaurus found in northeastern China also tell us an interesting story, especially when compared to the bones found in South Africa, which would have been in southern Pangaea at the time. Chinese Lystrosaurus bones have a high degree of something called lags, short for lines of arrested growth. These lines indicate that an organism ceased to grow during tough times. In South Africa, lags are rare in Lystrosaurus bones, but that doesn't mean South Africa was a better place to live. South African Lystrosaurus grew very rapidly, but also only lived for quite a brief time. Their Chinese counterparts, on the other hand, did live longer, as is evident by the lags in their bones. Long story short, the Turfan Depression during the early Triassic was a tough place to live, but survivable nonetheless, at least for Lystrosaurus. What does this mean for the humans? It's difficult to say, but considering that the humans have survived for thousands of years at this point, they would have been well adapted to the environment by now. Mountain sickness, or CO2, would not be the biggest issue at hand anymore. The biggest threat during the late Smithian thermal maximum in the early Triassic would be the dry periods that made its way to the Turfan Depression. If they had developed efficient ways of storing water, for example in pots or maybe even more complex methods, then I would say the humans would have a great shot at getting a silver or even a gold medal. The Turfan Depression was and is roughly the size of Spain. This means the human population would have had time to grow as they adapted to the conditions there. Overall, I'd award the humans that arrived in the Turfan Depression just before the worst pulse of the Great Dying a hypothetical gold medal, meaning that they survived Earth's worst extinction, the period of extreme heat that followed, and have done well in the early Triassic, even having outlived Lystrosaurus. Of course, this scenario is very hypothetical, but hey, I feel good knowing that there was at least one place where survival could maybe have been possible during this time, for us, instead of immediate guaranteed death. Let's leave our group of 20,000 Neolithic hunters behind. It's time to move to the modern world. How would modern human civilization react to a new Great Dying? Spoiler alert, saying it would be an absolute disaster would have been an understatement. There's one crucial factor that could greatly swing the chance of our survival in our favor. The timing. Unlike the meteorite that wiped out the non-avian dinosaurs, the Great Dying was far from instantaneous. Even the climax of the extinction happened over the course of thousands of years, which in geologic terms is very brief, but in human terms is a very long time. Therefore, if the extinction had a slow build-up of increasingly violent volcanic activity, we could probably predict that a mass extinction would occur in the next few thousand years. But if the damage to the atmosphere remained small in the early stages of the extinction, humanity could keep developing new technology to reverse the damage done to Earth. And if this slow build-up phase takes 5,000 years, who says we won't already have terraformed Mars by then? Of course, if we survive long enough to not have killed each other by that point. However, planet Earth was already in decline around 2 million years before the Great Dying. With a great dose of optimism, humanity could maybe have survived if we had many thousands of years to prepare for the worst, even in suboptimal circumstances. However, for the sake of entertainment, let's hypothesize what it would be like if the conditions of Earth today suddenly reverted back to those of the late Permian, without bringing back the supercontinent Pangaea. The real Great Dying took around 60,000 years with a margin of error of 48,000 years. Did you know that the rate of CO2 that was being pumped into the air at this time was slightly slower than the rate at which we are doing it nowadays? Nonetheless, if we continue to release fossil fuels into the air at our own ludicrous pace, we would only be between 30 to 50% of the levels of CO2 during the late Great Dying by the year 2300. One key difference here is that we have the means to drastically reduce our rate of CO2 emissions on a scale of just years, or maybe decades. The Permian wildlife did not.
Oh shit, here we go again.
There is some debate on how the release of CO2 played out in the Great Dying. Some researchers say there were 2 or 3 pulses, each with varying degrees of lethality. What does seem to be the case is that CO2 levels were at their highest not during the Great Dying, but directly thereafter in the early Triassic. Earth remained quite a terrible place to live for up to 5 million years after the disaster, and arguably, the period right after the extinction was even worse for life than the extinction itself. Technically, the early Triassic would have been called its own mass extinction if there were any ecosystems to drive to extinction in the first place, which was hardly the case. The problem with modern human civilization is agriculture. Agriculture is infuriatingly demanding, and the entire system would likely crumble within just the first few years. This is especially true considering there is ample evidence to support that there were smaller pulses of carbon just 10,000 years before the Great Dying actually began. It is important to know that even before the die-off started, CO2 levels were already maybe twice as high as they are today. After the event, it could have been between 6 and 20 times higher than today. Again, the current levels are around 400 parts per million. CO2 becomes toxic at around 2,000 parts per million, which could easily have been half or maybe even a quarter of the early Triassic levels. This would be very, very bad. With farming being impossible, billions would die and the few remaining would be plunged back into the Stone Age. Even if we did have the time to see the disaster of the Siberian traps coming far in advance, we would already struggle to feed our population with the declining environment we live in. After the first eruption of the Siberian traps, or if you prefer a more contemporary alternative, maybe the East African Rift Valley, a volcanic winter would follow. This doesn't just mean Earth would be cooler for a number of decades. Volcanoes cause a lot of pollution besides just CO2. We wouldn't have to wait long for our global food system to completely collapse. The pyroclastic clouds would block out the sun, and acid rain would further ruin any chances of possible sustained agriculture. When farmland reserved for crops acidifies and dies out, I'd predict we'd hit a tipping point of irreversible doom. Billions of us would die within just a few years. Like the Turfan depression in the Permian, there would likely be refuges where life wasn't affected as severely. Humanity's race to reach all these places would be chaotic, to say the least. This would be worse than any immigration crisis you can imagine nowadays. Here are two scenarios that could happen. 1. These refuges become a political tool and the countries where they are located can deny refugees from coming in, or wars will be fought over them until only a few lucky people who were already in these refuges would be the only ones to survive. They would have to make do with a post-apocalyptic world. 2. The influx of refugees in these safe zones reaches critical levels. People will either face mass starvation as a result of overhunting of the local wildlife, and keep in mind that most of us have no experience with hunting like our ancestors, so that's another major disadvantage, or diseases will spread like wildfire, killing most of everyone. In conclusion, considering that there are over 8 billion of us today, I doubt that all of us would be killed off. However, the only way we would be able to continue hanging on is with various much smaller groups, so we don't decimate the local wildlife ourselves. The modern day Great Dying should already take care of this. Environmental disasters, political chaos, starvation, and mass disease make one hell of a potent cocktail. One thing is imminent: the end of modern human civilization as we know it. The ones left remaining would be in a constant struggle for survival, trying to find enough food and not get poisoned by that which they do find. Humans could stick around for a bit, but considering how lethal the environment stayed after the Great Dying, I wouldn't be surprised if we couldn't even manage to outlive the humble Lystrosaurus. So, at least a bronze medal for our 21st century humans.